Hello all, welcome back to my channel. So in our previous video, we discussed on the concept of inheritance in C++. So here in this video, we will try to explore the concept of function overriding or the runtime polymorphism and abstract class or the pure virtual function in C++. So when it comes to function overriding, so it is nothing but redefining your base class function in the derived class with the same name, same return type and same parameters. So redefining the same function with the same return type and the parameters or the function signatures. So let's explore this with a simple example. So just think that you have a class, uh, say shape, and let's take maybe two protected variables. So int height and also int width, and let's have a public function, say wide area. So let's print cout base class area. Okay, done. Okay, so let's also have a derived class. So class, say for example any shape, for example maybe a rectangle, and let's derive it from the shape base class, and then we'll have a public function again. So here in this public function, we will have to use the same function. As I mentioned, function overriding is nothing but redefining the base class function with the same function signatures. So let's put this here. Okay, but instead of writing the base class, it's a rectangle class or the derived class or the child class area. Okay, so now we have a base class and a derived class, and we have derived, we have done a runtime polymorphism here, which is the example is nothing but function overriding. So let me create a, of course, a child class, that is a rectangle class object, maybe that is r1, and let me call r1 dot, what is that, area. Okay, so also inside this area, what I'll try to do is just to explain you guys, let me just call the base class, that is nothing but yeah, shape, yeah, shape and area. So what it should print basically now is first it should print rectangle class area, then it should print base class area. This outputs I'm supposed to get. So let me just save this. Okay, and I think all is good. Let me just run this. Okay, I think, yeah, the semicolon is something that I have missed. So let me just add the semicolon after the class. So yeah, run this. Yes. So if you see, first it called the rectangle class area, that is a child class area. Then it called the base class area. So function. So this is an example, simple example of function overriding runtime polymorphism. Example for runtime polymorphism. Okay. Now let's discuss about abstract class or pure virtual function. So just think that you have rectangle, circle, or triangle, multiple, what do I say, multiple child classes, and in each shape has its own area. The formula for area is different in each shapes. Like for rectangle it's different, for circle it is different, for triangle it's different. So in such cases you need to redefine this function in multiple child classes, and you really don't want any body or function body here in the shape, I mean the base class. So in such cases, what you can do is you can just remove this. You can make this virtual, okay, because you will be redefining in multiple child classes. So virtual void area equals 0. So this is nothing but your abstract class or the pure virtual function. This is an example how you implement this pure virtual function. So let me do one thing again here. Let me like show you like exact implementation. So let me just take the value of height and width here. So uh, void set underscore height maybe, and maybe int h. So okay, so h equals the capital H. Similarly, let me just copy this function and let me set the width as well. So width, and instead of capital H, it's capital W here, here as well, and a small w here. I think these things you guys already know if you have watched my previous video, like the same, the productive variable I'm just accessing here, then assigning the value that I get from the driver code or from the main function. Yeah. So let me just save this. Now we have a base class, two protected variables which can be accessed by the child classes or the derived classes. Then I have a pure virtual function which is like which don't virtual function or abstract class is nothing but a class which has this virtual function which is equated to 0 or which do not have any body. Okay, then I have set the values of height and width here. Okay, done. Now in the rectangle class I just calculate the area. Yes, I calculate the area. So as I mentioned, the return type should be same and also parameters should be same. So I have used the same function here with the same signatures. Now let me just calculate the actual actual area. So let me just put it as area rectangle equals, so it is rectangle height into width. So length into breadth or height into width. Yeah, star width. Then and L maybe. Yeah. Okay, now similarly let me create maybe triangle maybe. Yeah, one more child class. So instead of rectangle, triangle. Okay, shape, this is correct, this is correct only. Yeah, it is half, like 0.5 star. Yeah, that's the only change here. I think this is all good. Let me save this. Then I think all is good. We have a base class called shape, and we have two derived class from shape, that is the rectangle and triangle with the different area. But see, the function name is same here. And here we have a pure virtual function or abstract class, that is now this is abstract class and we are deriving from here. So virtual name I have used here. Okay, now virtual keyword. Yeah, now let me illustrate this again for you. Okay, let me create a object of both the child classes, that is rectangle and triangle. Okay, triangle T1, rectangle R1. Now firstly let's calculate the area of R1. Let's give the height and width maybe. So set height maybe to 10, and also rectangle dot set width maybe to 5. Let's calculate the area right away. R1 dot area. So done. So the area should be how much? It should be 50. Let's see that. But yeah, meanwhile let's do this same thing for the triangle as well. So let me just change it to T1. That's it. Okay, T1 dot area, sorry, control Z, control Z. Here it is, T1 dot set height, T1 dot set width, and T1 dot area. T1 dot area. So I think good. So it here it should give 25 and above it should give 50. So let's run this. Let me save this and let me just run this. And if you see, the output is as expected. Area rectangle is Okay, why does it give? Okay, because yeah, I did not change it here, so let me just change it to triangle here. I missed this, my bad. Save this and save this, run this. Okay, so area of rectangle is 50 and area of triangle is 25. Similarly, you can do it another way also by using a pointer, creating a pointer to the base class. Let me just illustrate that as well. So shape and maybe a star ptr, and let's make this pointer to hold the address of yeah, the child class, that is r1. Okay, and let me just call directly ptr. Yeah, you can set width and height, it's already been set, so I don't have to set it again, but you can do it. And area, let me just call this. Similarly, later on with the same pointer, let's make it to point to the triangle. So address triangle object t1, and ptr equals, yeah, area, and yeah, same call. So this is done, so it should print the same output again. Yeah, so it will be like four times, yeah, print. Yeah, so let's save this, the value will be the same. Let me just run this. Yes, so this was regarding, yeah, runtime polymorphism, the function overriding, the abstract class, or the pure virtual function. So thanks for watching the video. If you like this video, please give it a thumbs up. Thank you.